Hi, and welcome back to the final video of the day, and it'll be on scaling blockchains. So let's take a look at the difference between scaling a computer system and scaling a blockchain. For most computer systems, scalability refers to how capable the system can handle a growing amount of work. And when it comes to blockchain, a scalable blockchain is one that can achieve a high TPS, also known as transactions per second. So for example, Bitcoin has poor scalability, where it can only perform about 7 transactions per second, as compared to Visa, which can perform around 1,700. And besides transaction speed, we also look at the cost and energy consumption of each transaction. And scalable blockchains are more useful and pragmatic, but there's also a trade-off involved, which has been covered in last week's video under the blockchain trilemma. So basically, it's very difficult to achieve scalability, security, and decentralization simultaneously. So there are two types of scaling, vertical and horizontal. So vertical scaling entails the expansion of a network by adding more power and memory to a system's core processing unit. So this means upgrading the system's hardware to give it more processing power and memory. And then horizontal scaling involves the addition of more nodes to the framework of an existing system. So this means establishing clusters of servers that can handle an increased number of incoming transaction requests easily. So overall, general scalability improvements are made through the utilization of this idea called layering. So in this idea, each component of a particular system forms to interact with its digital counterparts in a sequential and hierarchical way. So next, here's just a very simple visual of the two types of scaling to give you a better idea of how it kind of looks like. So for vertical scaling, it's done by improving the efficiency of each individual transaction. So something to consider is vertical scaling means making each internal component of a system faster and stronger, but this would require supercomputer nodes, which means only a selected few individuals are capable of running such nodes. And then for horizontal scaling, so it's achieved through increasing the platform's overall throughput capacity, which just means its processing capability. And then something to consider would be how horizontal scaling tends to increase the security of a network, but generally results in the overall performance of the system being degraded. So when should you use horizontal or vertical scaling? Well, it really depends on the nature of the issue. So for example, if there's an issue with the virtual machine and its local memory is insufficient to process all of the transactions, a vertical scale might fix this problem. And on the other hand, if it's an incoming transaction load cannot be handled by a platform and it's existing hardware, and then a horizontal scale would help to rectify this issue instead. So one way of scaling would be using the Lightning Network. So it's a second layer technology applied to Bitcoin that uses micropayment channels to scale its blockchain's capabilities to conduct transactions more efficiently. So transactions conducted on the Lightning Network are faster and also less costly, which makes more readily confirmed than those conducted directly on the Bitcoin's blockchain. So by taking transactions away from the main blockchain and making them off the chain, it decongests the Bitcoin blockchain and also reduce associated transaction fees. So the Lightning Network can also be used to conduct other types of off-chain transactions involving exchanges between other cryptocurrencies. So with this added layer to Bitcoin's blockchain, it will enable users to create payment channels between any two parties on that extra layer. And then these channels can exist for as long as you want to. Because they're set up between two people, transactions will be almost instant and the fees will be very low or even non-existent. So to do so, firstly, you have to create a multi-signature wallet where both parties can access it with their respective private keys and then deposit a certain amount of Bitcoin. And then you can start performing unlimited transactions between the two parties. And then The actual distribution of funds actually happens only when the channel gets closed, and then the algorithm uses the most recently signed balance sheet to determine who gets what, and then this information is broadcasted to the Bitcoin blockchain. So in short, the Lightning Network allows users to conduct numerous transactions outside of the main blockchain and then records them as just one, where you don't have to keep a record of every single transaction on the blockchain. So let's just evaluate this Lightning Network, some pros and cons. So some pros will be higher transaction speed, lower transaction fees, and also greater scalability. There's also cross-chain atomic swap, which means blockchains that share the same cryptographic hash functions will allow users to send money from one chain to another without a third party. And then also anonymity, because transactions made outside the main blockchain are almost impossible to trace. And then for some cons, firstly, security. So since this system works on top of the blockchain and not have security, it's more likely to be used for just smaller transactions. And then secondly, potentially support centralization in payment. So since the Lightning Network doesn't really support offline payments, it's a similar situation when it comes to peer connections. So if one of the peers is unresponsive, then users might have to be forced to wait for hours on their end before being able to get hold of their funds again. And then thirdly, non-user friendly system. So the apps running on Lightning are not exactly very accessible to like novice people. And then also, one thing to note is that currently the adoption of the Lightning Network is relatively low, but it has been seeing a pretty steady growth and development over time. And next, we have forking. So to increase a network's transaction processing limit, it requires changes to be made to the technical workings of a blockchain. So this process of updating or upgrading a blockchain is called a fork. And this can be soft or hard depending on your purpose. So you can just picture a blockchain as a straight path made of blocks linked to one another, like the one in the picture here. And because all the blocks are chained together through a consensus that all the blocks agree upon, any upgrade to the system requires a change of consensus of all of the blocks. So such a consensus is very unlikely to occur because the blocks are linked through a functionally immutable set of rules. So thus, instead of rewriting each block, changes to a blockchain are often achieved using a fork. So a fork is an event on a blockchain that copies the original software and adds the desired changes to it. And because the two blockchains cannot coexist, the new blockchain splits into two branches, forming a fork-like diversion from the main blockchain. So firstly, with the hard fork, the rules of the blockchain protocol are updated or changed so that the old blockchain and the resulting blockchain are incompatible. So this means that the old nodes will not accept the newly updated blocks, and the new blockchain will operate on new rules that continually reject blocks from the old blockchain. So this is often referred to as backward incompatible software update. So if one group of nodes continues to use the old software, while the other nodes use the new software, this is where a permanent split can occur. So next we have an example on Bitcoin's hard fork. So firstly, we have a Bitcoin Classic. It was a proposed hard fork from the original Bitcoin blockchain that aimed to increase the maximum possible size of transaction blocks. So despite some initial promise, Bitcoin Classic has failed to be widely embraced by the Bitcoin community. And next up, we have Bitcoin Unlimited, which allows users for a bigger block size. However, concerns that miners with bigger resources would dominate the profit-taking means that it has also failed to take off. And then next we have Bitcoin SV or Bitcoin Cash. It's a coin born out of two competing Bitcoin Cash camps. So the first camp, to maintain the block size at 32 megabytes, is the most successful cryptocurrency coin of the Bitcoin hard forks to date. And then the second camp, which is to increase the block size limit to 128 megabytes. So the network split was mainly due to a disagreement in how to increase the transactions per second to accommodate for demand. And lastly, there's Bitcoin Gold. So this fork was implemented in the hope that mining on graphics card will make mining more accessible for normal people. So you can take note that a hard fork can actually occur in any blockchain. It's not just a Bitcoin thing. And then moving on, we have the soft fork, which is a forward compatible change to the rules, where the old blockchain will continue to accept blocks from the newly updated blockchain protocol, even though there's a change in the rules because of the new software. So all mining nodes meant to work in accordance with the new rules will then have to upgrade their software. So put simply, a soft fork tricks the old blockchain into accepting the new rules, therefore accepting both the updated blocks and the old blocks of transactions at the same time. And thus, unlike a hard fork, a soft fork maintains the old blockchain by maintaining two lanes with different set of rules. So this contrasts with a hard fork, where the nodes will stop processing blocks following the changed rules instead. So for this, we have an example. So segregated witness, or SegWit, is an implemented soft fork change in the transaction format of Bitcoin. So the declared purpose is to prevent non-intentional Bitcoin transaction malleability, allowing optional data transmission and to bypass certain protocol restrictions with a soft fork. And it was also intended to mitigate a blockchain size limitation problem that reduces Bitcoin transaction spend. So SegWit fixed an issue called transaction malleability, which allowed Bitcoin transaction data to be changed before the network processed these transactions. So this would have created a bookkeeping nightmare by allowing signature information to be stored outside of a block of relevant transactions yet still verify them. SegWit allows Bitcoin to keep the integrity of transactions while also packing more of them into any single 1 megabyte block. So the result would be a faster and safer Bitcoin. So despite the benefits of SegWit, not all participants in the Bitcoin network have implemented it. So to understand why requires familiarity with many roles that people play in the Bitcoin ecosystem and how sometimes the incentives behind them contradict one another. So for example, Bitcoin doesn't simply just upgrade. It relies on wallets, exchanges, and companies using it to upgrade themselves and push changes to the network accordingly. So if no one mandating this SegWit adoption, it's really up to engineering teams to nudge their organizations in the right direction, and it doesn't really always turn out as expected. So in conclusion, with SegWit, Bitcoin blocks can be scaled up from 1 megabyte to 4 megabyte, and the average transaction is around 380 bytes. And next, let's have a short comparison between the two types of forks. So soft forks are considered the gentler option of the two, but possess their own risks. And the most prominent of these risks is the fact that a soft fork can be used by bad actors to trick full node users and miners into validating blocks that violates the rules of the blockchain. And then hard forks, on the other hand, are not without their own set of challenges. So firstly, hard forks are known for dividing communities. Unlike the soft fork, there's no middle ground with a hard fork. And second, many argue that hard forks are dangerous because they split the hashing power of the network and therefore reducing the network security and processing capacity overall. So from this video, you should have a clearer idea of blockchain scaling and also forking. So systems that achieve greater scalability with different consensus mechanism do so almost universally by reducing the size of the set of a block produces. So if the root cause of the scalability problem is that every transaction must be validated by a node, one way forward is to simply reduce the number of nodes in a network. And then to decide how to scale, we have to consider that pure vertical scaling is limited in its effectiveness, but it's comparatively easier to realize. And horizontal scaling helps to improve the general throughput of a system, but also takes longer to develop. So in order to raise an understanding of difficulty, it often examines the bottleneck performance of a system. So bottleneck just represents a situation where excessive demand in a system affects the performance of a platform. And next, comparing hard and soft forks. A hard fork refers to a radical change to the protocol of a blockchain network that effectively results in two branches, and one that follows the previous protocol and one that follows the new version. And then on the other hand, a soft fork is backwards compatible because all nodes will recognize the new blocks as valid. And this kind of fork requires only a majority of the miners upgrading to enforce the new rules, as opposed to a hard fork that requires all nodes to upgrade and agree on a new version. So thank you for your kind attention today, and I hope you've enjoyed learning more about Bitcoin and Ethereum. So next week, you guys can look forward to learning more about the cryptocurrency space and also decentralized finance. And bye!